Hi and welcome to video 9, Unit 4, Topic 1, Financial Maths, General Mathematics, Year 12. And in this video, we're going to look at solving problems with compound interest. So this is the last component of this section of Topic 1. But of course, there are some future sections, so these videos will go on. This is referring to exercise 7E for those people using the Cambridge textbook. And it really outlines a range of different problems that you might face, and how we can solve those using both a calculator but also to an extent a spreadsheet. But do keep in mind that obviously at this stage we're gearing this towards questions you might receive in an exam, and you won't have access to a spreadsheet in an exam. So whilst it's a really handy tool to know how to use, if you are practicing for your exam, it's not going to be as helpful. So you've already seen most of what you need for this section, so I'll just zoom in on what I'm talking about here. And we know that A, or AN, is the value of the investment after N years, but it might just be written as A. We know that P is our principal, the initial amount. We also know I and N, I being the interest rate and N being the number of time periods. We have to be very careful, because if we have gone to compounding monthly or weekly, then I and N have to transform to the number of months or weeks and the interest rate as a weekly or monthly rate, for example. So just be careful that you've got your time period in the correct associated compounding period. And it's probably the most common mistake that I see moving forward with these topics. We also know, and we've talked about this a bit, that there is a connection between compound interest and recurrence relations. There is with simple interest as well, but we're just talking about compound interest today. And that connection is between compound interest and geometric sequences. And so A0 is just the principal, but after 1 year, the amount is the principal times by the growth rate, which is 1 plus the interest. 1 being 100% and the interest being a percentage. And then we multiply by 1 plus the interest again to get the second time period. 1 plus the interest again to get the third time period, and so on and so forth. And it leads to P times 1 plus I squared, P times 1 plus I cubed, and eventually P times 1 plus I to the power of N, which naturally leads to the formula that you all know and love. So you've seen where that formula comes from, geometric sequences, and we are able to use that formula, which we will be today in some of the examples I do later. We can also rearrange this formula. So we can rearrange A equals P times 1 plus I to the power of N to get P by itself, just by dividing through by 1 plus I to the power of N. And so if you knew the final amount but didn't know how much was originally invested, you could use this variant of the formula to calculate the principal. We can also rearrange, and this one's a little bit trickier, to get I, the interest rate, as the subject of the formula by dividing through by P and then taking the nth root. And of course the nth root is the same as to the power of 1 over n, if you recall your index laws. And then of course we subtract 1, and that will give us our I as a decimal. Remember, I in the formula is a decimal, so if it comes out as 0.12, that implies 12%, because we multiply by 100 to get to our percentage. So you can memorize those formulas, but it's probably better to just know how to rearrange. This formula is on your formula sheet, so if you can rearrange that formula, you can get to these without memorizing anything. And the rearrangement doesn't take that long, and it's actually going to be for you really easy if you're doing it when you do the practice questions. So every time you do one and you know that you need to find I, do the rearrangement rather than just copying the formula down. You'll find that you get really good at it and you know the rearrangement, and that way if you forget the formula in an exam, you've got that backup. Just a quick note, you may have noticed that we've talked about finding A, P and I, but not N. We can generate a formula for N, but it involves something that we don't do except in math methods and beyond. It's called logarithms. So if you don't know logarithms, well then N is quite hard to find. We can also find N using trial and error or a spreadsheet approach. You might be asked to find an N in the exam, and in that case you probably would just refer back to the trial and error and trial through a process of guessing N and seeing how close you can get. But I doubt that you'll be asked to find N. If you are asked to find N in the exam, don't try and rearrange. Just go to that trial and error and that will be perfectly fine. And now time for some light-hearted entertainment.
What did the pencil say to the monkey? Nothing. Pencils can't talk.
Let's look at some examples. I'll do one example to finish this video off, and then I might make a second video to cover the other two examples that I've got here. So the first example is Olivia is saving for a holiday that will cost $7,000. If she can get a rate of 2.7% per annum compounded yearly and has 4.5 years in order to save, what must she invest now to have enough? So the trick here is to first identify what are you trying to find and what do you know. So I'm going to have a quick look through this. I know that I is equal to 2.7%, and that's a per annum interest rate, but it's compounded yearly, so I can leave it as 2.7%. I'm happy with that. And I can also write that down now as 0.027. That's the decimal version. I know that N is equal to 4.5 years, and we're compounding yearly, so I can leave it as 4.5. And I know that Olivia needs to get to $7,000. So I know that A is equal to $7,000. That's where she wants to get to. And I'm trying to find P. Now, the obvious answer here is to do something on the lines of A, well, actually, I'm going to use the rearranged version. So A equals P, 1 plus I to the power of N, which means, therefore, that P is equal to A over 1 plus I to the power of N. And we can throw some numbers into that and get an answer. But there's a slight problem with this question that we need to deal with, which is why I've introduced it here, to just talk about some problems. So most of these examples are going to give you a straightforward example, but with something to consider on top. So let's throw our numbers in here. 7,000 over 1 plus 0.027 to the power of 4.5. I'll just put that in my calculator now. So that gives me $6,209.13. Now this seems a little bit unrealistic, because if I was saving for a $7,000 trip and I had $6,209 and I had to wait 4.5 years just to get that through compound interest, well, I reckon I could probably find a way to save $800 in that preceding 4.5 years through other methods. But it is a low interest rate, so we're kind of expecting that. And it's quite realistic for the current times we're living in. These low interest rates exist, and I'm making this video in 2020 if you're watching it in the future. So there are quite low interest rates, so it's fairly realistic in that respect. Later on we'll do a topic on annuities, and that will talk a lot more about what happens if you are saving, earning compound interest and investing regularly on top of that, and that's a little bit more realistic in this case. But there it is, there's our answer. The issue is that we have got a compounding yearly but over 4.5 years. So technically, if you took this question a little bit further, you would probably go to here and recognize that you haven't got 4.5 years worth of interest, because it's only compounding yearly. So in that 4.5 years, this investment will only compound 4 times, and you won't have received that extra half a year of interest. It will be there and you will receive it. Even if you withdraw the money, you get half a year's worth of interest, but probably not to the end of the year. So realistically, you're probably better off saying, well, I need to invest enough so that I only get 4 years of interest and it will be enough. So it'll be $7,000 over 1 plus 0.027 to the power of 4. And that's equal to 6,292.40. So that's what you'll need to invest, just to be sure, depending on how the interest works within your investment situation. So there's example 1. I'm going to leave this video here, and you can have a play with that. Hopefully you spotted the issue with that question, but if not, just keep an eye out as you're doing your questions to consider those issues that might arise. All the best.